If you like this video, please don't forget to smash the like button and share this video with as many people as you can. And if you are not subscribed to my channel yet, please kindly do it so that you don't miss any of my videos. So without any delay, let's get started. And today we are gonna learn about the string. Today we are gonna learn about C string library that makes it easier to do operations on strings. So if you don't know about strings, do check out my arrays video in C that I uploaded 2 days ago, and there I'm explaining strings also, so do check that out. And let's start with the video. Damn! So first of all, we are including io.h, our header file, and then we have to include another header file to use our string library, that is our string.h header file. Okay, so this is important to include. Then what we are doing, we are learning about the copy and cat methods, string copy and string cat methods. Over here we have a main method that will return 0. It will return an integer value, and we are creating a string, right? So we created like this: char string 1. There will be 9 characters in this. Basically, the last one is occupied for our terminating 0, a string terminator that is 0, and its value is first. And then we have our string 2 that will also be of 10 characters, 9 characters for characters, and the last one occupied for a terminating 0. Over here we are saving second, and these all are less than or 9 characters, right? Then we have our string 3 that can contain 19 characters. The last character will be for our terminating 0. Then what we are doing, we are copying. So to string copy, what we do, we pass the destination and then the source. So we pass it where we want to copy our value and which value do we want to copy. So in string 3, we want to copy string 1. So whatever value is there of string 1, that we want to copy in string 3. And if there was a default value of string 3 or a previous value there was there in string 3, then it would be overwritten because we are copying the string 1's value. So over here, if I had high in this, so that would be overwritten. It won't be high first, it will be high, there will be no high, so that high will be overwritten. Let's try to run it once again. Not running. We have other ways: gcc main dot c dot slash a dot out. So so over here, if you can see, we don't see any high in the concatenated result. We don't see high, so that's because string copy overrode the value that was there in string 3 to the value of string 1, that is first. So first high was overridden by first, so now first is there in string 3. Then we are using the string cat method. This string cat method says whatever previous value there is in that string, concatenate basically add a value to the previous that is to the value that is already there. So there is first already there in here. Then when we say to add in string 3 string 2, this will add all the value second in our previous value that was first. So now our string 3 will be first second because we use a string cat method that does not override the whole value, it adds to the value, right? So it added to the value string 2. So now in string 3 we have first second. So then we are printing %s plus %s equals %s. So first %s is replaced by string 1, the second one is replaced by string 2, and the third one is replaced by string 3. So this will show us first plus second equals first second, and that was what the output, that is what the output is, right? So this is the output that we expected. Then this over here can be an issue. This is our issue over here. So when we are using the string copy or the string cat methods, then we need to copy or concatenate the values in very separate memories. We can't copy in the same memories. They should be completely different memories where you can copy your strings. So for example, over here you're copying in string 1 plus 1, and then you're copying string. So you're copying string 1, that is first, in string 1 plus 1, and now this can lead to an unpredictable behavior, right? So this can lead to an unpredictable behavior. You cannot predict what this will do, right? So this is very unpredictable. And then we are printing string 1. So what is the new value of string 1? We copied string 1 in string 1 plus 1. So string 1 is pointing to the first character of our string 1 plus string 1 plus 1 will be the next memory location that is there to string 1. So the next memory location that is there in string to string 1 to the first character of string 1 is i's memory location, right? So that is i's memory location, and on i's memory location we are copying string 1. So now this can be two results. This can bring two results, I think. F first, so it can bring F and then first written, or it can bring F first RST. It could be any of the two. So we find the result is F first, right? If we just do the same GCC and then A dot out, so we see F first, right? So this is bringing F first. So over here from I, it is overwriting all the other characters also, right? So from I, it is overriding all the other characters too. So you should not do this. Please, you should not do this, right? You should not try it also. Okay. So over here we are now on how we can compare strings. Another common requirement is to be able to compare two strings to see if they are the same. As we have already seen, we can compare numeric values with the double equals to operator. So we know that we can compare the numeric values with the double equals to operator. But this doesn't work with strings. You can't use this with strings, because remember that the name of the string is really just a pointer to a location in the memory containing the string's first character, right? So it contains it is just a reference in the memory to the string's first character. So using equals to compare two strings will only tell you if they are at the same place in the memory. So when you use equals to compare two strings, then that will only tell if their memory locations are same, right? It will not tell that if their values are same. Not if two strings not if two strings are strings at different locations are the so using double equals to compare two strings will only tell you if they are at the same place in memory, not if two strings at different locations are the same. So it will not tell you that if there are two strings at different locations but their value is same. You can use the double equals to operator to compare two character variables. You can compare two character values using the double equals to symbols, right? And a string is an array of characters. So as we know, in our arrays video we saw that strings are just an array of characters. So it's possible to write a simple piece of code that compares each character in a string in turn, right? So that is how we can compare two strings with a simple code. So over here what we have included stdio.h, and then we have our main method that will return an integer value that is 0, and then we have our character, so this is our string 1, right, that contains first in it, and then there's string 2 that contains fire in it. Then we are creating a pointer variable, pointer 1, and its value is string 1, right? So string 1 is the memory location of our first character in our string 1. So that is this f character's memory location that will be saved in pointer 1. And then in pointer 2 we are saving string 2's first character's memory location, right? Quite cool. And then we are creating a while loop while string star pointer 1 is not equals to 0. So as we know, at some time the string reaches to its string terminator, that is 0, and we are checking till it is not 0, till the string till we have not looped through all of the string 1's characters. And then it is checking if till pointer to memory location, in pointer to whichever memory location is saved, that in there, if in there is no 0, then you can run this loop. So this is basically checking that if we haven't looped a lot and reached to the end of our both of the strings, then in the loop we are checking if our we are dereferencing pointer 1 to check its value, if that is not equals to pointer 2. Over here also we were dereferencing the value to compare it with 0, right? Over here also with pointer 2 we were dereferencing the value and checking if that is not equals to 0. In this we are rereferencing and checking if the value that is there in pointer 1 is, so the value that is there in pointer 1's whichever memory location pointer 1 is saved, the value there is not equals to the value that is there in the pointers to memory location that is saved in there. So if when we dereference pointer 1, that value is not equals when we dereference pointer to that value, then we just break, right? So the memory locations that are saved in both of these pointers, if that in those memory locations if the values of both of them are not the same, then completely break. If they are the same, then it will continue with the code and it will just do pointer 1 plus plus. So this will go to the next memory location of our whatever previous character's memory location was, and then it will go to pointer 2's next character memory location. So let's see what will happen over here. It will first of all see if star ptr1. So ptr1 has the memory address of f. So if f is this checking is not equals to 0, so f is not equals to 0, and then it will check if star pointer 2 is not equals to 0. So star pointer 2, so when we dereference pointer 2, right, then we'll get this f, that is also not equals to 0, so it will go in. It will check if star pointer 1, that is f, is not equals to star pointer 2, that is f. So they both are equal, so it will come down, right? It will ignore this break statement and come down over here. It will increment pointer 1, so it will go to the next pointer 1 will have the next character's memory location, that is I for string 1, and then it will go to pointer 2, whichever memory location was saved, it will add 1 to it, so it will go to the next memory location. So the next character's memory location, that is also I in fire. Then it will repeat the same thing and it will find they both are equal, so it will go to both the R's and then it will repeat the same thing, and it will go um, to S for our string 1, and it will go to E for our string 2. And then when it will check that if star pointer 1 is not equals to star pointer 2, that will be true, so it will break out, right? And then it will check outside that if star pointer 1 is equals to 0 and star pointer 2 equals to 0, then it should print the two strings are identical. Else it should print the two strings are different, because star pointer 1 will be only 0 and star pointer 2 will be only 0 if this has gone till the end, right? So if this had gone till the end, then it will be 0, right? So if this statement at some point is false, then only they will be 0, right? But if it breaks out in between, this statement will be never this statement will never be false, so that is not false. So that's why, because this statement is checking that if pointer 1 and pointer 2, the memory locations in both of these that are saved, they in those memory locations, if the 0 is not saved, then run the loop. And if this whole while loop is done, that means now pointer 1 and pointer 2, the memory location they are saving, both contain 0, right? So they both contain 0. So if they both contain 0 and reach till the end of the string, so this means that if it had reached till the end of the string, this while loop, then just print the two strings are identical, because it knows that nowhere it found a different character. Else just print the two strings are different, because if it broke out of the loop in between, that meant that it had found different characters. So that's why it those both point um, um, those both will not be 0, right? So the two strings are different over here because first and fire are different. If we give first and first, then the two strings will be identical. So the two strings are identical. Quite cool stuff. But you see now that how we can do it like in a flash using our string library method, right? So when we include our string header file, and then over here we are returning an integer value that is 0, and then what we are doing, we have a string 1, we have a string 2, and then we are checking if and string cmp, that is for compare. So string compare string 1 and string 2, so it will compare both the strings, right? It will compare both the strings, and then it will return 0 if they both are identical. It will return some other value if they both are not identical. So over here we are checking that if the return value of this method is 0, that means they both are identical, because it will only return 0 if they both are identical. So if it is 0, then we will print the two strings are identical. Else we will print the two strings are different, right? So this has shortened our code so much. Over here this will show the two strings are different because it won't return 0. It won't return 0 because the two strings were different, right? And if we just run this, we'll see the two strings are different. And then if we just make them the same, then it will show us that two strings are identical. Quite cool stuff over here. Now we have a similar method, very similar method. So this is also a very similar code. We have almost the same code, but we have used the string n compare. So string n compare, and this is for where we can add a third item also. So over here what this is saying, that it will this string n compare method, when we are passing it string 1, string 2 and string 3, this is saying that compare string 1 with string 2, not the whole strings but only its first 3 characters. So this will only compare the first 3 characters, that is FIR and FIR for both, right? So these first three characters are the same, right? That's why string and compare will return for us 0, right? And because it is returning 0, we are printing the two strings are identical. If it didn't return 0, then we will print the two strings are different, but it is returning for us 0. That's why it will show us the two strings are identical, though they are not, but their first three characters as we specified to compare are equal. That's why the two strings are identical, it is showing. But if we give 4 over here, then it will compare the whole fire with force. So now force and fire are not same. It will not return 0. It will go in the else statement and print the two strings are different. Quite cool. You got the point of it. Now we have something more over here. So this is also a very similar code, but we are using the string case compare method, right? So we are using the string case compare method, right? So we are using the string case compare method, and what this method does, whatever is the case of our argument of our strings that we want to compare, that wouldn't matter. So if this was first in all capital and this is first in all small, string case compare will give us that it is equal, but um string case string compare will give us that it is not equal, because string case checks for the case also, whereas string case compare does not check. String compare checks for the case also, and string case compare doesn't check for the case. So over here, this will give us the two strings are identical, right? This is giving us the two strings are identical, right? Quite cool. But if we had done the same thing with string compare, is it like this only? Yep, it is. I'm such a slippery brain person. So this is showing us the two strings are different because their case is different, right? Quite cool. And then we have another similar method, that is string n case compare. So what this will do, this will just work like string n, but it will ignore the case. So if we just do over here string 1, string 2, and then it should compare the starting three characters. So it should compare 4 with 4, but over here if you notice the F is capital, but still because we are using string n case compare, that's why it will work. It ignores the case. So over here it will show us the two strings are identical. If we didn't give case, then it would have it wouldn't have ignored the case, and it would have shown the two strings are different, right? So we can see that. Quite cool. Now we have another method, scanf. Let's see what this does. So over here we don't need to import our string library over here, and we have our integer val, and then we have a string that has 250 in it, but as a string, right? And then what we are doing, we are calling the scanf method, and what we are doing, we are giving it string, we are giving %d, and then we are giving and val. So then we are printing the value in the string is whatever the value is, and then we are returning 0. So what is the scanf method doing? So this scanf method is what it is doing. It is saying to search in string. So this will search in string. Wherever it finds the decimal over here, it will find, it is saying that on this position, it will find a decimal value. And it does find 250, that is a decimal value. So on that position, it got a decimal value, and we passed it the pointer to val. So now this it finds over here the decimal value, and whatever decimal value it finds, that it will set as val's value. So in val we will have 250. So in val, uh, um, the value in it is showing us the value in the string is 250. So it is, we are getting 250 over here, right? So over here we are getting, when we are doing scanf, the string, it is seeing, it is searching in the string that over here on this position in the start only it should find an what we say, an uh, decimal integer, so basically an integer value. So it found an integer value that is 250. So it set the value as whatever we passed it to set it to. So over here we pass the reference to our val variable, so that it can change the value of our val variable from a method. So we have learned that we need to pass our methods a pointer. We need to pass our methods a pointer to we need to pass methods pointers, so that they can change the values of variables that are there in our main program. So that's what we are doing to with scanf. So let's see some explanation over here that it's written. scanf uses exactly the same format specifiers as printf. So it has the same format specifiers as printf. One important difference though is that the arguments to scanf must all be pointers. So when we were accessing string, it was bringing our first element's memory location, right? So it was bringing our first element's memory location, so that was a pointer. And then we give the string that has format specifier that it handle itself. And then when we passed over here also we passed and well the memory location of our value variable. So that was also a pointer to our value variable, right? So one important difference though is that the arguments to scanf must all be pointers to variables rather than variables themselves. As always, a function can never change the values of variables provided as arguments, but it can write to their destinations if they are pointers. That we all know. You can check whether scanf was able to match the format specifiers with the string provided by looking at the value it returns. So what you can do, you can check whether scanf was able to match the format specifiers with the string provided by looking at the value it returns. Scanf returns the number of values it successfully read. So it will return us the number of values it successfully read. So for example, if a format specifier of person D is provided, but the string supplied doesn't start with a decimal number, scanf will write nothing to the supplied pointer and will return 0, right? If the string supplied does start with a decimal number, scanf will return 1, right? So over here scanf is returning 1. What is happening, over here, so over here what is happening, whatever in our string it was searching for person D at the start only, and it found a decimal, so it copied the value in our value variable, and then we showed our value variable that was 250, right? So if the string supplied does start with the decimal numbers, scanf will return 1. The format string supplied to scanf contain multiple format specifiers and even other text. So over here, the format string that is supplied to scanf can contain multiple format specifiers and even other text. Right? Sorry, right. So now over here, this is our example. That over here we included stdio.h. We have our int main, right? And then this is returning an int value, so we are returning 0. We have an integer val, and then we have a result string that has 10 characters. 9, and the last one for our string terminator. And then we have our string named string. It can hold up to 25 characters, 24, 25th one for the string terminator, and its default value is the first number is 1. Then we are doing if s scan f. If s string scan f, string the s number is %d, result and val equals 2. Let's understand the statement. So it is searching in string, it is doing the, right? So the % test number is %d. So we specified a format specifier %s and a format specifier %d, right? And then where it found, if it found %s, so if it found a string over here, it found first over here, so that's why that will be copied in result, right? And it will till now it will return us 1. And then it is checking if it found %d over here after is, so it found 1 over here, that is a decimal after is, so that 1 will be the value of our val variable, right? And we were able to give result like this because result is basically pointing to the of our result string, right? So that's why we were able to give result like this. And so now it found a decimal over here after is over here, after number is over here, so that it set the value of our val variable as that decimal, and now it will return us 2, right? So now it will return us 2 because so over here so over here so over here it so over here the string supplied when we compared with the string supplied over here, the our string also matched and our decimal also matched, so it will return us 2 because both of them match successfully, and it is 2, so that's why it will print string equals %s and value equals %d, and we are replacing it by result and val. So string equals result, that is first, and value equals val, that is 1, right? Else if it could not find both of them, right? So like if it could not find a decimal over here or it could not find a string over here, then I couldn't find two values in that string and it will return a 0, right? Quite cool stuff over here. So over here it will show us string equals first and value equals 1, right? So that is what it is showing us, right? Quite cool. And over here, if we instead of a decimal gave some character, then it will show us I could not find two values in that string. So it couldn't find two values in the string. I hope you got the concept. Note that slightly inconsistently the inconsistently the %s format specifier denotes a pointer to a string in both printf and scanf, right? So the %s format specifier denotes a pointer to a string in both printf and scanf, while the %d specifier denotes a variable in printf but a pointer in scanf. So %d specifier denotes a variable in printf. So this %d is denoting a variable val in our printf statement, but a pointer in scanf. But this decimal specifier is denoting and val, that is a pointer, right? So pointer in scanf. One thing to note about scanf is that it is in the standard IO library, so we didn't have to include a string library, right? Not the string handling library, so you don't need to include string.h to use it, right? Quite cool. Then we'll see how we can calculate the length of a string, right? So over here now we'll see how we can calculate the length of that string. So this is lu. So over here what we have our integer main, right, and it will return an integer value, and over here we have a string one that has first in it, and what we are printing the length of string is %s. So the length of string is %s of the string, the length of the string %s is %lu. Lu is for long unsigned, right? So unsigned, it stands for long unsigned. So string length returns us a value of unsigned long. So the format specifier for that to show is lu, %lu. So that's why I had to use %lu instead of t over here, because it is returning us us an unsigned long value, right? So it is returning us an unsigned long value. So over here we are replacing %s with string 1, and then we are replacing sorry, my lips, oh sorry, it hurts. And we are replacing %lu with the length of the string of our string 1. So the length of our string 1 is 1, 2, 3, 4, 5. So the length of string 1 is 5. So over here it will show the length of the string string first is 5, right? And then it will return 0. So the length of the string first is 5. Quite cool. And now over here we'll see an extra part which is terminating strings in between. You can use the string terminate 0 to terminate the string in between. Let's see how. Over here we have included stdio.h and we have included string.h, and this method will return an integer value and it is returning 0, and we have a string 1 that has 10 characters and it has first. What we are doing, we are printing our string 1, right? And then what we are doing, we are changing its third indexed character, so 0, 1, 2, 3. So this s character to 0. So we are changing this s character to 0. So now this has been changed to 0, and wherever it finds 0, the string gets terminated. So instead of s, in that memory location 0 will come and the string will be terminated there and then. And then when we print our string, we will see the terminating string and we are only seeing 4. So over here first we saw first, right? And then I forgot to add a new line. So first we saw first and then we saw third, because on our in the s characters place we added 0. So we added 0, so the string terminated there and then, and 4 was left in the string. But one more interesting thing is that if I do string 1 4, then see, so what is string? But okay, so there was an issue. So string 1 4, the format are what? I don't know why it is showing it like. Oh, so let's let's just check it on Google. How to show string character in C. So it is showing us %s, and then if I do string 1 4, so one warning, and then it is showing first, and then it is showing a segmentation fault. Why? Just why? So it was a character, so that's why we had to show it like %C. I forgot. So the interesting part is that we still have T in the memory, though the string got terminated on S position only. Still, we didn't clear that T character in the memory, so it is still lying in the memory, right? And this was so interesting, guys. So this was it, guys, for this video. I hope you liked the video. If you did, don't forget to smash the like button and share this video with as many people as you can. Thank you, guys. Bye. Stay safe, stay healthy, and keep watching my videos. Damn.